This video will show how to set up a Wago Bluetooth wireless radio. We'll start by looking at the master node. We have a power supply here and a 750-880 PLC connected with Ethernet. With two I/O modules, we have a 4-channel digital in, a 4-channel digital out, and the Bluetooth module 750-644 connected with an SMA connection to an antenna. The IP address for the master node is 192.168.1.3. On the remote node, similarly, we have a 750-881 with a 2-channel digital out module and the Bluetooth module connected with the antenna. The remote node's IP address is 192.168.1.4. We're going to start by going into the IO check software, and we're going to look at the 880, which is the master node. I'm going to click Identify, select the module for the Bluetooth, and we're going to change the Bluetooth module to be the master and change the name to be the master as well. I'm just going to resize the window here and start another instance of IOcheck 3, and this time we're going to connect to the 750-881, which is the remote node. And again, we're going to click Identify, click the Bluetooth module, go into the settings, and this time we're going to name the module Node 1 and click Write. Now click on the PI mapping and adjust slot 1 to be 12 bytes and click Write. And then go back into the settings on the master. And here we want to adjust slot 1 to be also 12 bytes. And we can adjust other slots. We can have up to 7 remote nodes. In this example, we're just going to do the one node, but this radio is a point to multipoint design, and you basically just adjust the number of bytes that you want to transmit to each node using this configuration tool. Now we're going to pair up the master with the remote. So if you go to the netforming and do a search for Wago 750 devices, you will see the node 1 that we just named. Move that over to the real-time devices and select yes from the drop down for bind and click write. And we're going to do similarly that for the remote node under netforming, only this time we're going to see the master show up, and we want to add that to the real-time devices and select yes from the drop down and click write. And then we want to click flash, which flashes that to the firmware in the device. Then we want to go into the communication real-time mode for both the master and the remote, and there's actually online diagnostics for this. So as you can see, for slot 1 we have connection completed here, and the signal strength is good. So this is an easy way to make sure that the previous steps have been completed properly. Now we're going to work on the actual application. We're going to go into Codesys and program the master first, which is again the 750-880. Enable web visualizations, and we're going to program this example in ladder diagram. We'll start by going into our PLC configuration and adding the modules that we looked at earlier. We have a 4-channel digital in, 4-channel digital out, and then the Bluetooth module. And you want to make sure you select the 48 bytes, which is the default data packet size for the Bluetooth module. And you can see the address there for the Bluetooth module is at IB0 and QB0. That's important when we're creating our data array for the communications. So here are my input and output data array of size 48 bytes. And I'm going to create a variable called node 1 seconds. We're going to bring a clock back from the remote node into the master to monitor it. And we're going to bring this in at IB4. That's one of the elements, the 5th element in the input data array. And I'm also going to add a remote DO on, and that's just an internal variable I'm going to use in my program. And that's going to actually be transmitted out the digital out to the remote node to turn the first digital output on. So in my ladder, I'm just going to create 2 rungs here. One is tying the internal remote DO on into the first array element in byte 4, And we're also going to do a remote reset, which is going to reset that clock in the remote node back to 0, so we can kind of gauge how quickly our communications is happening. So again, we're just going to put that into the second element of that output data byte 4. To facilitate our testing, I'm just going to create a visualization here, PLC Visu. Some of this is somewhat advanced. I have some other videos you can look at if you're unfamiliar with setting up visualizations here. Just creating a couple objects, tagging them to the variables I have in my global variable list. So this will be the digital output control, and here we're going to put in the node 1 seconds that we're going to be monitoring. Just hitting F2 here to bring up the list, the pick list. Just change the colors a little bit. All right. Little documentation. I'm just going to cut and paste this now. That's my digital output control. This new tag will be for the reset function. Tag that to the remote reset variable. Okay, so now we have a little interface to control our remote node. I'm going to create a new project for the A81, which is the remote node. Again, we're going to do this in ladder. Start by setting up the PLC configuration. We have a 2-channel digital output and the 48-byte Bluetooth module. Again, IB0, QB0 for our in and out on the Bluetooth module. And I've cut and pasted some variables from a project I already created. You can take a look at that if you want to freeze frame, but it's very similar to the master node. Just have some variables tied to the Bluetooth address, as well as the DO for the first channel to turn a light on. And we're just going to tag the data coming in on that same bit in the byte coming in from the Bluetooth module from the master. And then we're going to do the reset byte that's coming in, and we're going to tag that to the second, which is, I guess, the clock reset. We need to generate the clock. I'm just going to create a simple timer on with a counter up to generate my clock signal. We have a real-time clock that we could tie into, but for this example, I'm just looking for something to be transmitted back to the master. Again, if you're unfamiliar with the timer on or CTU, we have some tutorials on my YouTube channel that kind of demonstrate how to do this. Create a new rung here, and we need to convert the C1 count, which is going to be counting up to 60, but it's a word. Need to convert that to byte, which is how the Bluetooth module is set up. Just a quick test here in the simulation mode. We can see that it is indexing the counter, and now we just need to go offline and add another rung and tie in our master reset for the clock, and that will put the count 1 back to 0. Okay, we're going to download that to the remote PLC now. Go back to the 880 and download that to the master, and you can see we are getting data from our clock already. We can go into the monitor mode on IOcheck 3 for our remote and just verify that our output actually is turning on, and it is. And you can see that the remote reset does reset the seconds on the clock back to 0, and we can verify that again by going online with the remote node, monitoring the C1 count tag, and you can see it's at 30, 26, 36, and now it's back at 0. Alright, so now that we've tested on the bench, it's time to do a field test. In this example, we're just going to go 100 meters outdoor. We are rated to 1 kilometer. So you can see here our master node, and there in the distance is the remote node. And this is less than ideal conditions. You really want your antennas to be mounted properly, but this does show that we are able to control the remote node at a distance of 100 meters. And then going back into diagnostics on the master, we can see and monitor what our signal strength is. And this is really important when you're doing field work to be able to troubleshoot communication issues, because if it's not communicating, you need to know why. And this concludes the Bluetooth demonstration. Hope you've enjoyed the video. Thank you.